Hello, my name is Mirella. I'm from Brazil and I'm a student of environmental engineering at São Paulo State University. And I'm going to present the research entitled The Evaluation of Centrifuged Water Treatment Plant Sludge Without Thermal Treatment as an Adsorbent for the Removal of Nutrients and Other Physicochemical Elements from Wastewater. As a brief introduction, I brought up some aspects of universal access to treated water, which is one of the objectives of the Sustainable Development Goals. For this to be possible, water must be treated. And as a result of this process, we have sludge. More specifically, water treatment plant sludge, which can be very damaging to the environmental resources and human health if this waste is disposed of in this wrong way. As a result, various studies have been carried out to find alternative uses for this material, which ties in with the aim of this work is to evaluate the absorption capacity of centrifugal WTPS in the post-treatment of wastewater. To give a brief overview of the methods, the samples were first collected and prepared for both the WTPS and wastewater. The physicochemical and environmental characterization of the WTPS was carried out. For the wastewater, only the physicochemical characterization was carried out, with different parameters analyzed for the two rounds of tests carried out. The factorial design and statistical analysis will be explained below. We opt for a factorial design to optimize the number of experiments and to be able to analyze the interaction between the chosen variables using a statistical method. For test 1, we used three variables: pH, mass, and contact time. This first part was carried out as a preview to understand how the interactions would be and to be able to work better on the next test. Therefore, test 2 worked with only two variables, mass and contact time, as well as adding central points to improve the reading of the results. A p-value of less than 0.05 was considered for statistical analysis, with normality tests carried out by Shapiro-Wilk. For parametric variables, the student's t-test was applied, and for non-parametric variables, the Wilcoxon W-test. Regarding the results, I will first talk about the physicochemical characterization of WTPS. The SEM analysis showed regular morphological structures of the particles. In the case SEM and X-ray, there was a predominance of the elements aluminum and silicon, both in elemental form and in the form of oxides. This is because the sludge was obtained from a water treatment plant that used an aluminum-based coagulant. To analyze the functional groups of the material, we used the FTIR technique, which showed functional groups identified in adsorbent materials or by other authors, such as alcohols, ethers, ketones, hydroxyls, and amines. The thermographmetric analysis showed that there was an initial loss of mass below 100 degrees Celsius, which indicates a loss of moisture, and in the range of 200 to 600 degrees Celsius, the loss of mass is related to organic matter and structural water. In the environmental characterization, it was possible to observe a neutral pH with a high moisture content because the material has not undergone any drying process. The organic matter content indicates a substantial amount of organic carbon in the WTPS. The high liquidity and plasticity values indicate that the material is highly plastic and can retain large quantities of water. Starting with the results of the absorption process, it was observed that experiment 5 obtained the best results for both phosphorus and nitrogen. For both, the longer contact time result in greater interactions, with a higher mass in the case of phosphorus and a lower pH in the case of nitrogen. In the case of COD, the best experiment was 7, with the interaction between a low mass and a higher contact time. For the second round of tests, where we worked only with mass and contact time, it was observed that in the case of phosphorus, a low mass have the best results, and contact time didn't seem to have a significant impact. For nitrogen, the best interaction was low mass and high contact time, with the best results for experiment 3. For COD, the best was experiment 1, with low mass and low contact time. In the case of the removal results for all the parameters, the best results were for experiments 4 and 6 of test 2. For color, the highest removal was 17%, for turbidity 69%, and for total coliforms and E. coli 96% and 97%. The conductivity results had no significant difference, so their removal was not analyzed. With all that has been presented, it is possible to conclude that centrifuged WTPS can be used as an adsorbent for wastewater, different from the studies found where the sludge underwent thermal treatment. This could contribute to the sustainability and management of this waste. Beneficial use can contribute to recovery of waste and compliance with the principles of the circular economy, since its application on a large scale can help minimize environmental impacts. These are our references. And thank you all for your attention and opportunity. And I would especially like to thank the authors who took part in this project with me. So thank you so much.